In this video, I want to show you how to use the most simplistic form of factorizing as opposed to some of the other more advanced forms of factorizing, and also how to solve using factorizing, and even why it is that you have to factorize before solving in situations where you've got basically a quadratic like we've got here. So let's take a question like this: 6x equals 9x squared. First step is to rearrange it so it's equal to 0. So why do we have to make it equal to 0? I'll explain in a minute over here, but let's explain how we did this stage here. Basically shift everything over to the left hand side or to the right hand side. So in our case we shifted everything to the left hand side, so this 9x squared jumped to the other side and becomes a minus 9x squared. So I'm not telling you the basics of how to rearrange equations, just going to tell you that you've got to do it. But you might be thinking, what happens if I moved it to the other side, the right hand side, like I said you could, and got 9x squared minus 6x instead of this, which is 6x minus 9x squared is equal to 0. Well, actually, they both give you the same solution, so don't worry about that. You can try that out by yourself. Rearrange it the other way around and see what happens. So we've rearranged it to make it equal to 0. The next step is to factorize. So factorize just means find the common factors. So what are the common factors between 6x and minus 9x squared? Well, 6 and 9, the common factor, or you can say 6 and minus 9, it's up to you how you read it, both have 3 as a common factor. So put 3 over there. The stuff outside the bracket is the common factor. So what's a common factor between x and x squared? Well, x goes into both of them, so x is a common factor. Now, you have to remember when you're factorizing that factorizing is the opposite of multiplying brackets out. What I mean by that is that when you factorize something, it will turn into something like this with a bracket in it. And when you multiply the bracket out, it should go back or multiply back to the original thing you factorized. So this thing here. So why do I mention that? Well, basically it helps you factorize because you say 3x times what makes this first bit here, the 6x. Well, 3x times 2 makes 6x. And then you have to ask yourself, 3x times what makes minus 9x squared? So 3 times what makes minus 9? You say 3 times minus 3. And then x times what makes x squared? X times x. So you basically factorize it like that. Just remember that if you've got an expression with two parts in it, or two products I call them, because this is a product, isn't it? 6 times x, this is a product 9x squared, but basically two parts, it's easy to recognize the parts because they separated with a plus or a minus, like these two parts are separated with a minus. So if you've got an expression with two parts, when you factorize it, the bracket inside over here will have two parts as well, separated with the same sign. So that's a minus there, that's a minus over there. So anyway, that's how it should look when you factorize, and that's what we've done. We said 3x times what makes 6x, 3x times 2, so 2 is the first bit there, and 3x times what makes minus 9x squared, 3x times minus 3x. And it's that's the factorized version of that, and it's still equal to 0 since since this is the same as that and this is equal to 0, that should still equal 0. Now, why is it that we had to make it equal to 0? Well, there's a very useful trick that we can use if we make the whole expression equal to 0 and the expression is two things multiplied together. So I'll explain very quickly here. So when you have two numbers that time together to make a 0, that means one of them have got to be 0. Let's just think about it. If you got 5 times an x is equal to 0, what does x have to be? X has to be 0 because that's the only way you get 0 when you times by 0. So this is actually that sort of situation. You've got two numbers timesing to make 0. You've got the 3x, which is considered one number, and you've got the 2 minus 3x, which is considered another number, and there's a secret or implied times sign in between the 3x and the 2 minus 3x. Hopefully you know that. So basically saying 3x times 2 minus 3x equals 0. That means either the 3x or the 2 minus 3x is 0. Now in maths, the way we do it is we say that both are equal to 0 for different values of x. So basically you're supposed to have two solutions coming out of this situation. And that's what you expect when you got a quadratic. Anything with any equation with a squared in it, that should give you two solutions. So anyway, this is going to give us two solutions, either 3x equals 0 or the 2 minus 3x is equal to 0. Now if 3x equals 0, x is obviously 0, because like we said earlier on, 3 times something is 0 means that something must be 0. In this situation we've got 2 minus 3x equals 0. Rearranging it a bit will give you, well, let's do the rearranging steps a little bit. The minus 3x jumps to that side, becomes a positive 3x, so 2 equals 3x, and then move the 3 to the other side underneath, i.e. So you got x equals 2 over 3 basically. I don't want to really go into how to rearrange equations. I'm assuming you could already do that. So finally, why is it that we have to factorize before we solve a quadratic equation like this? Well, if we try to do it the normal sort of way where, you know, just rearrange it so x is a subject, we would actually have to end up divided by x. Now if you divide by x, you're turning this quadratic equation into a non-quadratic. Quadratic equations have two solutions, and if you divide it by x, it turns into what we call a linear equation. And a linear equation only has one answer, so we're changing the kind of equation we get, and we're basically reducing the solutions we're going to get. So if we divide it by x, we would have got 6 equals 9x, and that would have solved to become x equals 2/3, ignoring the other solution, which is x equals 0. So we can't do it the usual way where we just make something the subject. We've got to factorize so that it keeps the solution.